In this video, we're going to talk about sets in Python. But first, we're going to talk about sets in mathematics because that's what the sets in Python are trying to simulate, okay? Unlike with variables, with functions, the sets in Python are pretty much as they are in mathematics, okay? So what is a set in mathematics? A set in mathematics is an unordered collection of unique elements, okay? So unordered meaning that there's no sense of this comes before that. Um, they're all at the same level. We usually draw them mathematically with a Venn diagram with a circle. Okay. So there's no relationship between them that way. And they're unique. If you add an element to a set that's already there, it just doesn't do anything. So there's never more than one in the set. Okay. In Python, we're going to turn this set into a data structure. We're going to use it to hold data, retrieve data, and manipulate data. Okay. Again, in Python, we're going to be able to use the in and the not in, just like our other data structures, to see if things are there. And we're going to be able to iterate with a for loop. Okay. So let's look at some set operations. Okay. Again, we're back to mathematics. I'm sorry, I'm switching back and forth. So the first thing is a union. Okay. The union of two sets. Okay. So in my examples here, I've got set A being equal to 1, 2, 3, B is equal to 4, 2, 4, 6. Okay. So the union then of A and B is the set of all the unique elements in A or in B. Okay. So it's going to be 1, because that's an A, 2 and 3. So it's everything in A. Okay. Then we add in not the 2, because we've already added 2, the 4 and the 6. So that's the union. It's everything in one set or the other set. Okay. The intersection's the next one. It's the set of unique elements that are in both A and B. So if you look, what's in both of these? 2 is the answer. So it's a set containing 2. Okay. Notice if there were nothing there, it would be the empty set, which is a 0 with a slash through it. Or in Python language, just 2 curly brackets. Okay. Now we use the curly braces for dictionaries, but with dictionaries, we had the comma. So if we just put it in with just the normal stuff, then there's not really a much of a reason to do that. In fact, there wouldn't. There's a different way. So ignore it. Forget I said that. Okay. So the union is in one set or the other. The intersections in both sets. Okay. The difference of two sets, the difference of A and B, and the order matters. It's elements in A but not in B. Okay. So 1 is in A, not in B. 2 is in B, so that doesn't count. 3 is in A and not in B. So 1 and 3 is the answer there. So note that the difference of B and A is different. The difference of B and A are those that are in B, but not in A. Okay, so in that case, 2 is in A, so that's not in the difference. Okay, 4 is and 6 is. So 4 and 6 is the answer there. Okay, and then our last definition is a symmetric difference of A and B. And that's a set of unique elements in A or B, but not both. Okay. So it looks like basically it's the union if you take away the intersect. Okay. So that's how that works. Okay. So creating our sets, it's different from the other things that we've seen before in that there is a set function. The set function is responsible for creating sets. Okay. You can create an empty set by just saying that my set is equal to set. Okay. And once you've done that, now you have a set. You can also, the set command also takes one argument. Okay. So it's important we only give it one argument where we can do multiple things. Okay. So if I say something like my set is equal to set ABC and then print my set, you'll note that it divides up the structure to the A, the B, and the C. Okay. If we send it something like this, okay, it doesn't, oddly, it took a little longer, which is funny. It doesn't throw an error. It just doesn't add it the second time. It adds an 1A, not 2 or 3 A's, 1B, not 2 B's, and then a C. Okay, so it doesn't care about that. Okay. So you can also add a list of things if you want. You can add a list. 1, 2, 3. Okay. That creates a set of 1, 2, and 3. Not an issue there. Okay. Note that you could not do this. If you wanted the words 1, 2, and 3, okay, it's going to give us an error. It gives an error because set only takes one thing. Okay. So how we can do that instead, we would have to create a list. Okay. If I have a list of those 3 words, now we're good. Okay. Interestingly enough, though, we said this was unordered. That just showed us, right? It stored it as 3, 1, 2. No reason, no rhyme. We can't do anything about that. Okay. And it turns out we can't directly access an individual element of a set. I can't give me the first element of a set or the last element of a set or any of that. Okay. It doesn't work that way. It's a group all the time. Okay. What I can do is that I can print it out. Okay. I can use the iterator. So I can say for let's say little s, define in my set, print s. Okay. That'll print the 3, the 1, the 2. Again, not in order, but it will print everything. Okay. So that is perfectly okay. No problems there at all with doing that. Okay. Note that S will take on, for each iteration of the loop, whatever the next element of the set is. Okay. And that's fine. Okay. Note that we can have mixed things. Okay. I can have a 2 here. I can have a 3. I can have a, I don't know, true. Probably can even have a list. I think. Let's see. Oh, nope, doesn't like that. Can't add a list. Oh, wait, I have it correct. Maybe I didn't. Oh yeah, I did. Yeah, can't add a list. But this should all be okay. Yeah, this is all okay. Okay. So that's how we add things to our list. Okay. So we can get the number of elements we have. That's okay. I can do the length of S. Tells us, gives an error. Oh, the bool had no length. That's interesting. Yeah, I'm not sure why it gave the length the way it did. You wouldn't put a true in there anyway, so let's just do that. See what we get. Does that work? Oh, the whole problem was that I was stupid. That wasn't the problem. I'm trying to do it inside of this for loop. That's not how that works. I can just print. Here's what I should have done. It's the length of my set. That should work properly. It gives us 4, which is correct. Okay. So that's how that works. Okay. If you want to add an element to the set, okay, you use an add command. Just add the new element. Okay. So I can just say my set dot add, whatever you want. 21. Okay. I can print my set again, and it's added the 21. Okay. So no issues with that at all. Okay. So we also have this update that allows us to add a whole new set of items. Okay. So I can, if I do a my set dot update instead of add, I can add in a whole list of things again, just like I did with the set. Okay. So you see, you've added those in. Again, they've lost all sense of ordering. Okay. So you don't have to worry about that at all. Okay. If you want to get rid of an element from a set, there's either the remove method or the discard method. Okay. Remove is going to raise a key error. Discard does not. Okay. And to do that, I can just say as an example, if I do my set dot remove 1, okay, it's going to be just fine. Okay, and if I print it again, move the print here, we see that the 1 is not there. Okay, if I try to do this again, or change it to something else that is not there, let's say I want a loan. Okay, that's going to be a key error. Okay, where discard doesn't care. It's fine. Doesn't do anything, but it doesn't throw an error. Okay, but if there's something there, it works. So that's how we get rid of things. Okay. We talked about using the for loop. Okay. If we're going to use the remove, we could do something like if 1 in my set, that will return a true or false. We could do a my set dot remove. Okay. And that would work. Okay. Again, if we change that to tone, then it makes no change at all, but doesn't throw an error. Okay. So you can also just to see if something's in a set, just say use the in, not in works the same way. Okay. But remember, you don't have to worry about checking if it's in the set before you add it. If you add it, it doesn't care. Okay. That's going to ignore you entirely. So again, if I have here my set dot add another 2, it just ignores you. Okay. No issues at all. Okay. Now let's set things up from the examples that I did up here, just so we can run through these operations here. Okay. So I'm going to have my set A be equal to the list 1, 2, and 3, just like we have in the problem at the top. Let's type it again. And B is going to be equal to set 2, 4, 6. Okay. So again, I can run it to make sure I'm not getting errors. Nope, life's good. Okay. So we're going to start. Okay. And I can create new sets here. I can say A UB for A union B is equal to A dot union B. Okay. I can then print A UB. Okay. Which gives us the 1, 2, 3, 4, 6, which is exactly what we expected up here. Okay. I could do the A intercept, or the intersection, not intercept, intersection, which would be A dot intersection of B. Okay. Print that. That says ain't, unfortunately, which is just 2, as we suspected. Okay. Again, you don't have to make it a new set. You could just you could do something else with it if you wanted to. I mean, I could say something like for X in A dot union B print X. I think I can do that. Yeah, that's fine. Okay. Because again, A dot union B is a set. So we're just doing a set membership here. I could also do something like if 5 in A dot intersection B print found, which this is not going to print found because it's not. Okay, but if I did instead the 2, then it would print found. Okay, so we can do that. Okay. Then we have the two differences. Okay. So the difference just by itself, the regular difference, is going to be things that are found in the first set, but not the second set. Okay. So if I do A diff B, we could call it. If it's A dot difference B. Okay. Then I can say for X in A diff B, print X doesn't like something. Did I spell difference wrong? I did. There we go. Okay. So what are the things that are in A but not in B? It's 1 and 3. Okay. If I just change the order here, I'll keep the name being wrong. The B diff A are things in A, things in B, not in A. Okay. And that should give us the 4 and 6, just like we thought. Okay. Again, the symmetric difference doesn't matter the order. So again, I'll just leave these the same way. And for that, we have this really long thing, symmetric. It's in lowercase. Underscore difference. Okay. Again, A, B doesn't matter. And that's going to give us the elements that are in either one, but not both. So as I've got up here, we've got 1, 4, 1, 3, 4, 6. Okay. Just to show if I would change that to A and B, no difference. Same exact elements. Okay. So that's all there is to it, two sets. Okay. So there's a in the spotlight in the book that starts in page 471 in my book, and it talks about having baseball and basketball players, okay, and things like that. Okay, so that's a good one to go through because you're using that, right? Because you want to know things like who are the people that play both baseball and basketball, okay? Who are the people that play any sport? So the union of baseball and basketball, okay? How many people in baseball but not in basketball? All those are kinds of questions that you can ask using a set, okay? Remember, again, there's no way to get to an individual element of a set. So if I say something like print a sub 0, it's going to go insane. Say it's not indexable properly. Type error. Yeah, it's not subscriptable. That's the idea. Okay. Oh, there were some other functions. I'm glad I said that subscriptable error or generate that. I didn't talk about it up here, but we have a subset of a group. Okay. So if we have A being 1, 2, 3, then a subset of A could be 1. Okay. So all the elements of the subset are in the main set. Okay. So if we had C is equal to 1, then we would say that C is a subset of A. Okay. We also talk about a superset. So a superset's going the other way around. Okay. So we could say that A is a superset of C because it contains all the elements plus more. Okay. So those end up being true false things. So I could say, put this in my code here. If I were to say C is equal to set of just 1. Okay. I could print C is subset A. Okay. Doesn't like something. Do I need to do something different there? No, it should be okay. caps lock off is subset of A. Okay. Should be okay. Oh, got too many of those. That is a real problem. Isn't that what I just said? I don't know. Something like something. Okay. What? Oh, it doesn't that look like that line? Oh, it has to be iterable. So I think I have to do that. Oh, that's giving the error from there. Otherwise, it should work. Yes, that works. Okay. Yeah, you can't just put things in there directly. It's got to be either a string or if you want an int, it's got to be in a list. It's got to be something that's iterable. Okay. So in that case, to say, is C a subset of A? Yes. Is C a subset of B? False. Okay. And then we can say, is A superset of C? And that should also be true. Okay. So is A superset of B? Should be false. It is. Okay. So that's what we do for sets. That's the whole idea behind sets. Okay. So again, we'll work on the examples tomorrow. Look through the Spotlight example would be helpful. And if you have questions, make sure you let me know.